It will say, got it. So now what I'm supposed to do? I'm supposed to reduce the view, exit full screen, and then I will go to the coordinate system thingy. Where on earth is that? That's in handouts. Where is that? Handout 271.
Which one do you need?
Hmm?
You have,
No, 271. I will put 271 coordinate systems. That's the one. Yeah. So I am going to go through the work, which is on page something, which is the example on page that starts on page 4. And I will also do the work for the exam problem that no one did. Okay. So now, and the point is that a 3-dimensional version of this is on the problem set, which you should do. So there's the tri-cylinder problem, which all of you should do. And you should also do the spherical polar coordinate problem. Okay. Incidentally, did you do any of the 263 problem set?
Yeah.
You did not start. That was from his class, the murder mystery. So that was when I was still, this was pre-COVID.
Right.
After COVID, it seems that very few people want to register online, in class, in person classes. So there's no comparison. There's no comparison. But in my case, it was not COVID. It was I had a throat problem, because of which I stopped. Okay. Okay. So now, this is the example. I'm going to work the example out. So in plane polar coordinates, so this is x is equal to r cosine theta, but this is no different actually, because the lectures will be recorded and you can listen to the lectures. And they all have that. And the other thing is that, so in case one doesn't come to class, they can always listen to the lectures. Yeah. But I was planning to go into a room and record the lectures, talking to an empty classroom. I don't know what that will be like, but I could do this. I should have Riviera review it and see if it increases the probability of being construed a monster, a computer monster, or decreases the probability.
Yeah, maybe someone work because if you go at your own pace, you might do the thing where you just start going faster throughout the entire.
Oh, they have always told me that I go very fast.
Yeah.
So,
but like so.
It's only because this is not entirely under my control that I am a little slow. I can write very fast with chalk. So let's see. So x is equal to y is equal to r sine theta. And on the exam we had, how am I going to do this? Side by side or one below the other? Side by side. Let's see how far we can proceed. On the exam, you had x is equal to AR cosine theta, y is equal to BR sine theta. So the first thing that is done here is the calculation of the Jacobian. So this is del xy del r theta. So that's equal to determinant of del r x del r del theta x del r y del del theta y. There's a reason why I'm deliberately doing it this way, because I told you that all you had to do is to copy directly what was in here, except that you change the value of x and y, which was a perfectly reasonable thing to expect, but no one did. This was on exam 1C. Yeah,
One was from the notes.
yes. This is in the notes, page 4, on coordinate systems. Sine theta. So determinant of cosine theta minus r sine theta r cosine theta. Oh, sorry, this is r. Just a moment. This is del del r. Sine theta and r cosine theta, which is equal to r cosine squared theta plus r sine squared theta is equal to r cosine squared theta plus sine squared theta is equal to r times 1, which is equal to r. And on this side, I do exactly the same thing, except that I haven't added, I have a factor of is equal to determinant of del del r of x, del del theta of x, del del r of y, del del theta of y. So this is equal to determinant of, I will be incidentally sending out more emails about strange rolling objects. And there's this Australian guy who, what is the name of his website?
His YouTube channel is called Maker News. It's
What news?
Maker News.
Make Your Muse, Maker's Muse, yes, yes, yeah. And he has many of these strange objects, which is very popular with techie teenagers. And he calls them the,
It used to be a tech.
yes, yeah. And he says that all these names like oloids seem alien to him. So it's not, I mean, mathematicians deal with alien stuff all the time. The funny thing is that this tricylinder occurs in the core of a cyanobacterium, which is found in plants. And so it must have some optimization property with respect to light harvesting, which I haven't found for which I haven't found a precise statement. So all these things actually occur in nature. And since you are an alien to this class, I will tell you that we talked about ellipsoids last time. And the Wikipedia article lists the estimation of the volume of the size of the prostate gland as an application, which turned Riviera off. But we all have prostate glands because there are only, as far as I know, men in this class. Nowadays, one doesn't know. And this is a very important thing to do because anytime you have internal organs, if you want to know anything about them, and you have no means of actually seeing it directly without chopping off or making incisions in the body, or inserting endoscopes through various orifices, then you have to have some way of measuring them. And the ellipsoid is an approximation that one makes, but this, although there's a hole in the middle. Incidentally, it's a very easy problem to solve if you have a cube and you make 3 holes in the middle along the 3 axes. What is the volume of the resulting solvent? This is an application of the inclusion-exclusion formula. You remember that long ago we found the cardinality of the intersection of 3 sets? All of you, it's cardinality of A union B union C minus cardinality of A union B minus cardinality of A union C minus cardinality of B union C plus the cardinality of A intersect B intersect C. Oh, I said unions. The second line will be intersections. So there's undercounting and overcounting. It's called inclusion exclusion. So that is what needs to be used if you have to compute the volume of a tube through which you have bored 3 cylindrical holes. There was a somewhat crazy plan once of using the curve of fastest descent to connect New York and California by digging a hole, starting in New York and ending up in San Francisco, and just letting something go, a vehicle, which would go, this should have the shortest time path, which is called a brachistochrone. And I forget what the time was. Somehow I seem to remember that we calculated it in a physics class, it was 0.4 seconds, but I'm not absolutely certain. Anyway, but the point is that this was not done, but this would be one day of travel. Just to go from New York to San Francisco along this tunnel in the shape of the least time curve. Yeah. No, for anything that you allow to fall along that hole, someone would put you in the hole in New York and you will emerge in San Francisco. Yes, yeah. But 0.4 seconds is what I remember. I didn't do this calculation today. I did several when I was an undergraduate. No, it's a curve of least time. You're not going along any curve. You're going along a brachistochrone, which has a very specific shape. It's a catenoid. So, but it was never put to use. I don't know, because I do not know the constitution of the Earth's interior along a hole from New York to San Francisco. I would not want to be the first to.
You have to go down a certain distance. I mean that when you start getting balls.
No, I don't know how much. I mean, if it is there's a specific catenary, so which is the shape of a hanging cable, but you have to. I mean, you can calculate the exact path, and then it will have to be somehow dug. And it will take a long time. It's not a short distance. Okay, so we go back to this. And so this is del R of A R cosine theta, del theta of A R cosine theta, del theta of del R of B R cosine theta, del theta of B R sine theta, sorry, sine theta, which is equal to determinant of A cosine theta minus A sine theta, B sine theta. No, B cosine theta, BR and BR cosine theta. So this is equal to ABR cosine square theta plus ABR sine squared theta is equal to ABR. Cosine squared theta plus sine squared theta is equal to ABR times 1 is equal to ABR. I am trying to point out that this is absolutely trivial and everyone should have done it, but no one did. There is nothing going on over here. Okay, so from this you conclude that del R theta del XY, which was also is equal to 1 over del XY del R theta is equal to 1 over R. And here, del R theta del XY is equal to 1 over del XY del R theta is equal to 1 over ABR. Okay, that gives you 4 points already, but no one did it. This was on the exam, not 4 points. Yes, maybe 4 points. Well, I certainly do not know why you didn't. Is del XY del R theta dr d theta in absolute value. So that is equal to absolute value of R dr d theta is equal to R dr d theta because R is always positive. The similar calculation for the unit volume over here is equally easy, but we will not do that for a reason. Okay, let's see what happens after that. Okay, thereafter it says in spherical coordinates, which is the problem on the problem set. That's worked out over here for the spherical polar coordinates, the Jacobian. So do not reproduce this work, just say it is on this page. This is the answer. Okay. Okay, now comes the next thing. So, which is the next example, which starts on page 7. Yeah. Is find Tn arc length, volume element, etc. So, and the what is it called? The level curves. So I will tell you in just a second. So if x is equal to r cosine theta and y is equal to r sine theta, from that you conclude that x squared is equal to r squared cosine squared theta, y squared is equal to r squared sine squared theta. If you add the two, you get x squared plus y squared is equal to r squared cosine squared theta plus sine squared theta, which means that this business you should be able to follow, Gabe. There's nothing, this is basic algebra. And the style is exactly as in 163, the deductions. So, did you actually interact with Rivera and Quinn wrote? Did you talk to? Okay. Okay. So R is the square root of x squared plus y squared. This is clear, right? Now I am going to repeat exactly the same thing on the other side, which is exactly what I asked you to do, but no one did, which is x is equal to AR cosine theta, y is equal to BR sine theta. Well, if you, so let me write it this way, AR cosine theta, y is equal to BR sine theta. So you divide both sides by A, divide both sides by B, and then you get x over A is equal to R cosine theta, y over B is equal to R sine theta. So these two correspond to these two. Right? So obviously R is not the same in both cases. Part of it, but I want to do the whole thing just so that you see. So x squared over a squared is equal to r squared cosine squared theta. Y squared over b squared is equal to r squared sine squared theta, which means x squared over a squared plus y squared over b squared is equal to r squared cosine squared theta plus sine squared theta, which means x squared over a squared plus y squared over b squared is equal to r squared times 1, which means that x squared over a squared plus y squared over b squared is equal to r squared. Taking the square root of both sides, we get square root of x squared over a squared plus y squared over b squared is equal to r. So these are the two relations between r and x and y in the two cases. Okay, here we have r sine theta is equal to y, r cosine theta is equal to x, and we know that r can never be 0. If you divide one by the other, you get r cosine theta over r cosine theta is equal to y over x. R's cancelled, giving me tangent of theta is equal to y over x. Take arctangent of both sides to get arctangent of tangent of theta is equal to arctangent of y over x. So which means theta is equal to arctangent of y over x. There will be ellipses, but no one over here remembered. So AR cosine theta, so it's a good thing that you said that that is the case. So that's proof by existence that someone remembers from pre-calculus. Yes, that they have all had Calc 2, but time has swallowed the knowledge. It doesn't matter. You took calculus 2 less than, I mean, the time lapse between your taking Calc 2 and this class is far shorter than the time lapse between my taking these things, which was in high school, and this class. And I don't practice these things. When you learn, you have to learn in such a way that you remember. That's the problem. Yeah, but what's the point of doing these things if you don't do it in such a way that you remember? This is what the educational system does. It says, here, do this. It doesn't matter. It is your brain and it is in your interest to prevent it from turning into a cabbage. It doesn't matter. I am 75 years old. Yes, and plus or minus 20. Well, it is true. I didn't specify the origin, so I am 75. Since the birth of Christ. Anyway, let's see. So, we didn't even have a wheel. What? Oh, just a moment. What did it? Well, that's fine. AB tangent of theta is equal to y over x. I did. Okay, so this means I have to multiply both sides by b over a. So that gives me tangent of theta is equal to by over ax. This doesn't seem right. Let me see. No, just a moment, because I wrote it wrong. B R A. So this is B, this is A. This is B, this is A. So this is A over B, A over B. So this is AY over BX. So if you take arctangent of both sides, But just today, Professor C.R. Rao, whom I briefly met in Pittsburgh when I was getting my doctorate, just won the award, the International Statistics Award, which is considered to be the equivalent of the Nobel Prize, and he is 102. He was an undergraduate much before I was born in Calcutta, which is the city I'm from. And we were invited once to his house. He taught at the University of Pittsburgh. I was in Carnegie Mellon. The house that I lived in had many students who studied statistics at Pitt. And I went with them. So I still remember. They have a picture of him. There is a video of him also. So he did this work in 1945. And that was cited as one of the most profound contributions. This is the estimation of statistical parameters. And he did it when he was 24. Someone asked him the question and he did it in an hour. Not in an hour, sorry, in 24 hours. He gave the answer the next day. But it took the statistics community a long time to understand that this was very profound. But he's in perfect, I mean, he's in perfect health and his head works perfectly well. Well, and you're not 102. Yes. Yeah, you have to wait before your head gets better.
Wait 7 years, we'll talk 7 years. It's fine.
With all black hair? That is true, yes. You are 32, I think. I mean, starting from when you were born.
I'm 20 years old.
So I was off by 4 years. That's not bad. Yeah. But computer science people do not age. Because computers don't cause trouble to you, and most computer science people are in love with computers and not with human beings. So that has advantages and that has disadvantages. You have to leave. Yeah. Okay, go. Nice to meet you. His name is Gabe Miller. So this is Byron Dees. This is Max or Maxim. Maxim Zabigalyuk. And that's Nathan Gapanoff. Nathan is a tutor. Yeah.
Yeah, nice to meet you guys.
Okay. So I hope you take my advice and take 270 and all the things that people, I recommend that people suffer through.
Even though I'm at the end of it and I have not done well this semester. Yeah, no, I'd like to.
Okay. Oh, incidentally, what was your impression of me before you actually saw me? Was it also a computer monster? No, but I would like to know what it was in actual descriptive terms, literally.
I think I was just wondering like what you're
No, you're not being complete. You can be completely honest. It doesn't matter. It's a statement of fact.
I was very shocked.
You were very shocked.
Yeah, I was
Okay.
like, I've never experienced such meticulous.
No, but that's a positive description. I want
I thought he was probably very kind of like a machine of a person.
that agrees with Riviera's. Riviera thought that I was I'm giving words to the expression that I saw on his face. Riviera, I think, thought that I was a mixture of a computer and a monster.
Yeah, no, I think you have a description of I am a computer, and this is what like, this, you have to talk to me like a computer, if you give me non-information, the computer doesn't do anything, put nonsense in, so just.
Yeah.
So it's like, this is nonsense, and I live with it.
Yeah, I mean, that's exactly how you describe.
That is true.
John Politis told me that the first time he talked to you, he said if you were to peel back your face, you just see circuits and wires.
There are circuits, except this is, of course, inside the brain. This is not wires in the usual sense of the term, but we have nerves and we have neurons, which effectively constitute the circuitry. I mean, in other words, and there's a word that computer scientists use, they call it wetware, as opposed to hardware. Software or dry, I don't know what dryware is actually. I've never heard of dryware anyway. Oh yes, I've been trying for a long time to prevent you from turning into cabbages and to brain dry you, because you've been brainwashed by horrible forces.
The weird part is slightly older, I think.
Oh,
the sinks.
you have to move. Yeah.
Can't believe it's not. I took essentially 5 years off of school. And it's-
Well, of course, it's getting worse and worse, but we will see. So I am producing I am imposing a force in the opposite direction, exercising a force in the opposite direction. Okay. See you. You're welcome. Yeah. So we have here theta is equal to arctangent of AY over BX. Okay. So in this case, we had R is equal to square root of x squared plus y squared. Theta is equal to arctangent of y over x. On this side, we had R is equal to square root of x squared over a squared plus y is squared over b squared. And theta is equal to arctangent of AY over BX. This already gives you 6 points. And this is absolutely trivial, in my view. But no one did. Yeah, that's a problem. That's a big problem. Okay, so now. Okay, level curves. R is equal to constant. R is equal to constant, which means square root of x squared plus y squared is equal to constant, which means square root of x squared plus y squared is equal to k. If you square both sides, you get x squared plus y squared is equal to k squared. Here, R is equal to constant. So square root of x squared over a squared plus y squared over b squared is equal to constant, which means square root of x squared over a squared plus y squared over b squared is equal to k. Square both sides, you get x squared over a squared plus y squared over b squared is equal to k squared. X squared plus y squared is equal to k squared is the equation of what? X squared plus y squared is equal to constant. You should know this. No, this is a circle. That's very bad. So if you change the value of the constant, if it is 0, it's this point. They are circles around the origin. In this case, these are, but all these are given in great detail in Wolfram Mathematica. These are ellipses. So these are like this. Okay. Yes, it could be oriented differently also, because depending on which one is larger, A or B. I just assume that A is larger. There's no reason to assume that. Okay. So this is trivial because you can ask the computer to tell you what curve they are. You should know, of course. This is, I mean, you know now that your prostate gland is in the form roughly of an ellipsoid with a hole through it. And its volume is 0.52 times 4 pi over 3 ABC. And these are the three axes that are estimated from a picture. It's actually a spheroid. That means two of the axes, two of the semi-axes are roughly equal. At some point in the future, it will be necessary to have it measured. And I hope that you remember, look at the ultrasonography to see. Okay? Of course you will do it now. Actually, that is a very good idea, because if you do it every year, you will see at what rate it is increasing. It only increases just as the bones do. You see, it's a gland. It increases in size because it surrounds the urethra. So the inner radius decreases because the cells form on the surface and the outer radius increases. The bones also grow like this. The bones grow this way. Yeah. Because the old cells are replaced with new cells. So
Get rid of some of the old cells. Get rid of some of the old cells.
no, the old cells are come inside. Yeah, because they change into the marrow and the surface moves outside. Very slowly, of course. That also you can do. You can measure the circumference of your bone, let's say the leg, and see. You know, these are very important things to do. I mean, that's a very good idea. Whether the doctor would let you do that, so just tell him that you want to keep yes, track of your body, yes. And you can do the same thing with the eye. The eyeball also grows like an onion. Nose also grows. Nose, ear, the eyeballs, there's a drainage. The eyeball actually squishes the drainage. And this can lead to what is called narrow angle glaucoma. Because then if the liquid can't drain, then the pressure builds up. If the pressure builds up, the optic nerve is harmed. Yeah. The optic nerve cannot take too much pressure, because in that case the nerve cells die, as far as I know. In the case of the urethra, what happens if the prostate gland, it squishes the bladder, so urination becomes difficult. So these are things these are simple plumbing problems, basically. Right? I mean, we have a plumbing setup within us. So you must understand. The more you know the structure of your body, the less likely you are to hurt it. Okay. So so you understand now what the level curves are? You set the coordinates is equal to constant. Okay. And plot them in the XY setup. Okay. Now, here theta is equal to constant means arctangent of y over x is equal to constant, which means y over x is equal to constant. Well, let's call the constant k. Right? The tangent of something constant is also constant. So that means y is equal to kx. Here, theta is equal to constant, which means arctangent of the ay over bx is equal to constant, which means ay over bx is equal to constant, which means y over x is equal to constant. Right? Because I multiply both sides by b over a. And constant times b over b and a are constants, so that is also constant. So that's y is equal to x is equal to k, so y is equal to kx. So this is just a line through the origin. This will be depending on the K, they will not mean the same thing. The theta does not mean the same thing in the two cases. Okay? So as a result, we get, so for different constants, we get different lines. So here we have circles with spokes. And here we have ellipses with spokes. Is this clear? Okay, but do you understand this thing? So you can set up a city in this way. So DC has a grid, ordinary rectangular grid with a polar coordinate superimposed on that. But the traffic was not the goal. But no city, as far as I know, has been designed in the way the human setup is designed. The human setup is designed as a graph with various centers. If you read the graph theory book, you would see that, so there are trees going from various places in different directions. So that is a good way to prevent clogging, because we have to have blood flow everywhere, right? So traffic flow, blood flow, these are all similar types of problems. Again, it must come back to the heart, where similarly, we have air passages, we have respiratory flow. We also have electrical flow along the nerves. We have lymphatic flow of the lymphatic fluids. Okay, so these are very nice things that you can try to understand using graph theory. This is not done, but there is no reason not to try it. Okay. So, for instance, you can think of viral transmission as essentially happening through a system of cells. And the infected cell can be considered a node, but an infected cell somehow must transmit the infection to other cells. This is essentially a graph theory problem. If you block the pathways cleverly, it would not be able to do that. So there are lots of applications of these things. Okay? Okay, so this is the first part. Then there's a bijection which is written over there. Let me write that down. So C1, C2 is defined to be R theta going to R cosine theta, R sine theta from 0 to plus infinity cross 0 to pi to S. So in this case, it would be C1, C2, sending R theta. R and theta are two different things in the two different cases. Okay? AR cosine theta, BR sine theta from 0 to plus infinity cross 0 to 2 pi to S. And eta 1, eta 2, oh no, not epsilon 1, sorry. Why did I write epsilon? Should have written eta.
Isn't that in the note?
Yes. It's not eta, it's epsilon. I should have written eta, because it's eta that corresponds to y, the Greek letter, which is in Cyrillic, it is this letter. That you call E, right, in Ukrainian? The letter that you just wrote here.
Oh.
That's an E, right? How do you pronounce it in Ukrainian? A. I see. Okay. In Ukrainian, pronounce it as A, I see. But it's nevertheless, it's the Greek eta. because eta is written this way. And that in writing becomes like this, which is also the English Y, which doesn't exist in Latin. That's why in French, etc., it is called the Greek E. The Y is called the Greek E. In French, it is called Y, which means the Greek E. Okay, so this is equal to. So how do you pronounce this name? Well, I will ask you later. Okay.
I tried to explain.
Yes.
This is the spoke,
Yeah.
and the rest I just did for it.
Yeah. But the spoke should not go through the circumference. It should go through the center.
It's going through this.
Yes. And that's the tangent. Yes. Yeah.
Yeah, the black line is the tangent.
Yes. Yeah. In your A must have been larger than your B.
Yes.
Yeah. So that's why your shape is that way.
I had 3y over 6. My A was 3 and my B was.
X squared plus y squared, comma, arctangent of y over x from S to 0 to plus infinity cross 0 to 2 pi. And in this case, epsilon 1, epsilon 2 would be r theta going to square root of x squared over a squared plus y squared over b squared, arctangent of ay over bx going from S to 0 to plus infinity cross 0 to 2 pi. These are actually bijections, and it says over there that you should check that they are. Oh, what am I doing? Okay.
This,
P is equal to xy. Rp, the radius vector for P, or the position vector, is OP, which is equal to xe1 plus ye2 is equal to x10 plus y01. So for that, we will have Rp in our case, OP is equal to xe1 plus ye2 is equal to x10 plus y01. So far, no change. This is the Cartesian coordinates. Okay. But from here, we get Rp. This is equal to OP is equal to x10 plus y01 is equal to r cosine theta 10 plus r sine theta 01. But in our case, from here, we will get this is equal to OP is equal to xe1 plus ye2 is equal to x01 plus y0, x10 plus y01 is equal to AR cosine theta 10 plus BR sine theta 01. Clear? We are doing exactly the same thing. Hence, del R of R. We have to compute the norm of that. Is equal to square root of del R dot del R is equal to square root of del R cosine theta R sine theta dot del R of R cosine theta R sine theta. This is done in the notes. So this is equal to square root of cosine theta sine theta dot cosine theta sine theta is equal to square root of cosine squared theta plus sine squared theta is equal to square root of 1 is equal to 1. Okay? So the scale factor H1 is equal to norm of del R of R is equal to 1. But in the other case, we would have del R of R norm is equal to square root of del R AR cosine theta, AR sine theta dot del R BR sine theta, AR cosine theta, BR sine theta. Okay? Is equal to square root of A cosine theta, B sine theta dot A cosine theta, B sine theta. Now you see, this is not as nice because we would have A squared cosine squared theta plus B squared sine squared theta. So we don't have as nice a thing in this case. Okay? Okay, so in this case, H1 is equal to the norm of del R, which is equal to square root of A squared cosine squared theta plus B squared sine squared theta. Note that this is not difficult at all. This is absolutely straightforward. I am just following exactly what is in the notes. We have to now calculate this, which is equal to square root of del theta R cosine theta R sine theta dot del theta R cosine theta R sine theta is equal to yeah, it worked. Minus R cosine theta, R sine theta dot minus R sine theta, sorry. Sine theta, R cosine theta, minus R sine theta, R cosine theta is equal to R squared sine squared theta plus R squared cosine squared theta is equal to R squared cosine squared theta, sine squared theta plus cosine squared theta, which is equal to R squared times 1 square root of R squared, which is equal to R. But in the ellipse, yes. What time is it now? Okay. So, yeah, so H theta is equal to norm of del theta of R is equal to R. Now, if you do the same calculation now, in the other case, okay, you would get del theta of R, which is equal to square root del theta of AR cosine theta, BR sine theta dot del theta of AR cosine theta, BR sine theta is equal to square root minus AR cosine theta, BR cosine theta dot minus AR sine theta, BR cosine theta. So this is going to be equal to square root A squared R squared sine squared theta plus B squared R squared cosine squared theta. And again, we see that this is not as nice a formula. This is R times A squared sine squared theta plus B squared cosine squared theta. Okay? So that therefore h theta is equal to this.
Fine.
Hmm?
Not bad.
No, it's not bad at all.
Yeah.
Yeah. So T1, where's T1? T1. T1 is equal to 1 over del R del R of R is equal to 1 over 1 del R of R cosine theta R sine theta is equal to cosine theta sine theta. In this case, T1 is equal to del R, sorry, one over del R del R is equal to 1 over square root of a squared cosine squared theta plus b squared sine squared theta. I think that's what it was. Del R, AR cosine theta, BR sine theta. So this is equal to 1 over a squared cosine squared theta plus b squared sine squared theta. R cosine, sorry, A cosine theta, B sine theta. Okay. Similarly, then T2. T2 is equal to T2, I will not do the spherical case because it is computed over there. Okay, so I'm just going to do the new case because Maximo has to leave. This is equal to del theta of R times del theta of R. So this is equal to 1 over square root of R times square root of a squared sine squared theta plus b squared cosine squared theta del theta of, what is it? AR cosine theta, BR sine theta. So this is equal to 1 over R square root of a squared sine squared theta plus b squared cosine squared theta minus AR sine theta minus AR sine theta BR cosine theta. Yeah, so T1 dot T2 is equal to 1 over R square root of a squared cosine squared theta plus b squared sine squared theta times the square root of b squared cosine a squared sine squared theta plus b squared cosine squared theta times the dot product of, what was the first one? I forgot. A cosine theta, b sine theta. A cosine theta, b sine theta dot minus AR sine theta. Oh, these r's cancel. So the r's will cancel out. So this is simply will simplify a little bit. So let me write that down. It's equal to 1 over square root of a squared sine squared theta plus b squared cosine squared theta minus AR sine theta BR cosine theta minus a sine theta. Minus a sine theta, b cosine theta. So that means we have 1 over R times square root of a squared cosine squared theta plus b squared sine squared theta, a squared sine squared theta plus b squared cosine squared theta times a squared sine theta cosine theta minus a squared sine theta cosine theta plus b squared sine theta cosine theta. So now you choose some theta which is not equal to, I mean, even you could even choose pi over 2. No, pi over 2 will not work. Let's take pi over 4. Theta is equal to pi over 4. If you do that, this will be, could you move a squared plus b squared over 2, a squared plus b squared over 2 square root, and this would be minus a squared over 2 plus b squared over 2. So this is equal to one over r times a squared plus b squared, 2 times b squared minus a squared over 2. The 2's cancel, so this is equal to 1 over r b squared minus a squared over a squared plus b squared, which is clearly not equal to 0. Because r cannot be 0 and b and a are not equal. Okay, so this shows T1 is not perpendicular to T2, so you do not have an orthogonal system. Okay, similarly, you have to compute gradient of, so this is equal to del x of square root of x squared over a squared plus y squared over b squared. Del y square root of x squared over a squared plus y squared over b squared. That calculation, well, I will do just a part of it. This is half x squared over a squared plus y squared over b squared to the minus half times 2x over a squared. And this is equal to half x squared over a squared plus y squared over b squared to the minus half 2y over b squared. So this is equal to x over a squared square root of x squared over a squared plus y squared over b squared. The 2's cancel. And y over b squared square root of x squared over a squared plus y squared over b squared. So norm of the gradient of epsilon 1 is equal to x over square root x over a squared square root of x squared over a squared plus y squared over b squared, y over b squared square root of x squared over a squared plus y squared over b squared, dot x over a squared square root of x squared over a squared plus y squared over b squared, y over b squared square root of x squared over a squared plus y squared over b squared. So this is equal to square root of x squared over a squared divided by x squared over a squared plus y squared over b squared times a to the 4th plus y squared over b squared over b to the 4th x squared over a squared plus y squared over b squared. This is not that bad. So this is equal to a squared x squared over x squared over a squared plus y squared over b squared plus b squared y squared over x squared over a squared plus y squared over b squared. So this can be pulled out. So 1 over square root of x squared over a squared plus y squared over b squared times the square root of a squared x squared plus y squared b squared. This can be written as AB over, sorry, AB is in the top. AB a squared x squared plus y squared b squared over b squared x squared plus a squared y squared. Okay, so similarly, this is therefore n1 now is equal to 1 over the norm of gradient of u1 of epsilon 1 times gradient of epsilon 1. That calculation I don't want to do. I mean, I have calculated everything, but it's not as nice as the polar case. And a little later, here you have the calculation of epsilon 2, and you will find T1, T2 and N1, N2 are not perpendicular to each other. Okay, and then you have all the other stuff. So these are the calculations that you need to do. Now, on the problem on the exam, you have T1, T2, T3, N1, N2, N3. Okay, let me do one more thing. So there's a alpha is a, phi is a vector field. XY going to XY from R2 to R2 cross R. How would you express it in polar coordinates? Well, in polar coordinates, you would say R theta goes to XY will be AR cosine theta times BR sine theta. Right? So that is R theta would go to ABR squared cosine theta sine theta. So you just use substitution to convert them. And then there's a little bit of calculation for the various, the gradient, divergence, and curve. Okay? It's a lot of calculation, but it is not undoable. And you had 3 weeks rather than 2. But everyone goofed off or tried to recover. One of the two. Okay? So this is as much as I'm willing to do. So I've told you enough. In spherical polar coordinates, it will turn out to be orthogonal, which means the dot products will be 0. And there will be one more thing. So in addition to del R of R, del theta of R, you would also have del phi of R. Okay? So you have to do all of these. Clear? Spherical polar coordinates, which is a problem in the problem set. So you should do this and also this. Okay? Yeah, one can never do
What is the 26th or the 27th?
Tuesday. Tuesday or Monday? Monday, yeah. Yeah. This is on Monday, it's due on Monday, but cosmetic changes until Tuesday. Okay? Okay, so first stop. Stop the recording. Stop the recording.